So if you recall, in MLPs, we first learned how to build one layer of MLPs, and then we extended it to deep MLPs, right? Similarly, even at convolutional neural networks, we learned how to build a convolutional layer and a max pooling layer, right? And a max pool layer. And then we extended it through, and we extended it by just layering one convolution and max pooling one after the other, and we built deep CNNs. Similarly, we can take the RNN units, the either simple RNN or LSTM or GRU units, right? We can layer one on top of the other to create a deep RNN. And a deep RNN typically looks like this. I'll draw a simple diagram so that you get a good idea of it. So you have your first layer, right? Of course, the input to the first layer are just zeros or random values. You have your xi1, right? It generates some output which goes to xi2, right? Again, which goes through xi3, right? You have your xi4. Let's assume there are 4 inputs here for xi. Let's just assume, okay? Or let's assume there are 5 inputs, okay? Just for the sake of it. Now, this is your, if you think about it, this is your layer 1. This is your layer 1. This is your input layer. This is your input. And this is your time axis. Remember, don't forget that this is your time axis, right? This axis is time. And this axis is the depth axis in the deep neural network, right? This, if you have more and more layers one top of other, it will be a deep RNN. But this is time step, the first time step, second time step, etc. Your outputs are anyway connected like this. And of course, you have your O's connected like this, and you have your YIs, right? These are your outputs. Now, each of these cells can be an LSTM. So these can be LSTM cells or GRU cells or simple RNN cells. Again, simple RNN cells are not used very often nowadays because they don't learn long-term dependencies. Most often, you simply have LSTM units or LSTM cells here. So this could be a set of LSTM cells, not necessarily just one LSTM cell. And you could have GRU cells. Now, one on top of the other. So the output of this becomes the input to the next layer. Of course, you have zeros to the first one, right? Again, the same structure continues. The same structure continues, right? So this becomes the input here, this becomes the input here, this becomes the input here. Now this output again goes to the next stage, right? So this is your layer 2. You can keep stacking one layer on top of the other layer, and at the end, I mean, depending on the problem, the actual structure of a deep RNN, is very, very problem specific. And in one of the simple examples we'll see later in this chapter, and also we'll see a lot of case studies later. We'll also see a lot of case studies where we'll show you how these how deep LSTMs are used in the real world. For now, the structure is like this. So this is the most important thing here, is that this is the time axis and this is the depth axis, right? This is your input layer, your layer 1, layer 2, and so on and so forth, right? So what happens is, for any layer, for any input here, for any LSTM cell, in the second layer, you get output from the first layer. Just like the way you're getting input from the input layer here, you're getting input from the previous layer. So this is basically stacking. If you think about logically, this is your layer 2, this is your layer 1 of LSTMs, and this is your time axis. That's very, very important to remember and to understand. And back propagation and forward propagation are very simple. Whichever direction your arrows are, your forward propagation happens in those directions. In reverse to that, exactly reverse to it, your back propagation will occur, right? So back propagation will occur both across time and across the depth. So you'll have two because you just reverse all the arrows, then you get the back propagation direction. If you just move all the arrows forward, if you just flow in the direction of arrows, you'll get your forward prop. If you flow opposite to the direction, you'll get back prop. All of the calculus, everything will remain the same. Nothing will change. The core concept in RNNs is these LSTM cells and GRU cells. Those are the key concepts. Rest of the structures, they're very similar to what we have seen in MLPs and CNNs. Nothing very fancy, nothing very different from that. The key thing you have to remember is that forward propagation happens in the direction of the arrow, and backward propagation happens in the reverse direction to the arrows that we have. That's why this arrow-like representation, that's why these diagrams are very useful, so that you understand how actually the propagation is happening forward and backward. If you don't have these arrows, it will be super duper confusing on how the backprop and forward prop are working out. Except that the core concepts are the same. And when you have a deep RNN, all of the machinery that we have learned, all of the machinery like dropouts, like batch normalization, all these concepts are still valid even in the case of LSTM and GRU, just like the way they were valid in the case of CNN, right? Just like in the case of CNN, if your output, you can also have flatten, and all those cases, you can have things like flatten, etc., even in deep RNNs. We'll see some examples later in this chapter, a real world example of actually taking sentences. We'll see an example where we take sentences of reviews of movies and we'll determine whether the review is positive or negative. Right? We'll actually take reviews from IMDb, which is a very, very popular website which has lots of reviews of movies. Right? We'll see an example so that all these dots, all these concepts will become much more clearer for you just a little later in this chapter. But structurally a deep RNN is very, very similar to just a deep MLP or a deep CNN, except that the core units now are LSTM/GRU.